Learning goal! Yay! Students will be able to graph an ellipse by finding its characteristics. Graph the ellipse.
It's a pretty high goal.
It is a high goal. So let's
Yeah,
I have to write this up there. We have to get A to be 1. We're going to set this up to complete the square twice. So we're going to get the x's together, we're going to get the y's together, we're going to make a little template to add a number on each one of these. Oh, I forgot the little template here. What am I supposed to do? Oh, now I know. All right. 4 divided by 2 is 2. 2 squared is 4. But what have we really added to this side? 36. We've not added 4. We've added 36. So we're going to add 36 over here. 2 divided by 2 is 1. 1 squared is 1. Well, we've really added 4 to this side. We have 9 times x plus 2 squared plus 4 times y minus 1 squared is equal to now 36. But in order to get the information that we need, in order to have it in a very convenient form, we need this to equal 1. And when we do that, we have lots of information. We divide by 36. That way this will be equal to 1. X plus 2 squared over 4 plus y minus 1 squared over 9. There we go, equal to 1. Once we get this all equal to 1, pretty straightforward to find all the information. I never found conics to be terribly difficult. It's just a lot to remember more than anything. The center is -2, 1. Don't forget to do opposite, of course. Easy to miss that if you go a little too fast. Well, let's get the information as we go. We got -2, 1. And then because 4 is under the x, from the center, to find 2 more points, we go right and left 2. We do the square root of 4. Right and left 2. And then because 9 is under the y, we'll go up and down 3. So up 3, down 3. And that's enough to graph the ellipse. Then with the vertices are always the farthest from the center. So the vertices are up here. They're up and down. And that's the point -2, 4. And the point -2, -2. So there are the vertices. The other ones on an ellipse are called the covertices, but we didn't ask for that. Foci. It's kind of like the Pythagorean theorem, a squared, except this one's minus b squared equals c squared. So if it's a minus in the equation, if it's a plus in the equation up there, it's a minus in the relationship between a, b, and c. With hyperbolas, that'll be a minus in the equation, and then we're going to have a plus in the a, b, and c. So it's nice that it goes hand in hand. It works the same way with hyperbolas. Well, you don't really have to know which one is a and which one's b. Just don't get a negative. Don't get a negative, then we get a square root of negative. So don't make the 4 the a squared. Well, the a is always the bigger one with ellipses. With hyperbolas, a is always the positive, or usually we say the first one. We need 9 minus 4 equals c squared. If you turn that around and make it -5, you're going to have a problem. You're going to have to take the square root of a negative number. So c squared is 5. C is plus or minus square root of 5. Now that's not the foci. The foci are actual points. Now if we were to get the decimal value for square root of 5, it's going to be a little over 2. Square root of 4 is 2. Square root of 5 must be a little more than that. That means the distance from the center to the foci is the square root of 5. So 2 point something. So the foci have to be in this neighborhood. 1, 2, a little bit over 2. They got to be somewhere right there. Now when you report the foci, I really don't want decimal values. Notice that the x values for the vertices, the foci, and the center, those are all the same. They happen to be -2. Well, then we start at 1. We go up square root of 5. From 1, we go down square root of 5. So that's 1. That's where we're starting. And to get the focal points, we go up and down the square root of 5. And that way you can do this without ever grabbing a calculator, and you can give me a very good answer for that. There are some decimal values for it, but I don't really care what they are. Major axis. That's the longer axis. That's on the line, x equals -2. So the major axis is really a line segment. But when they say, what's the major axis, we give the equation for the line. The minor axis is the shorter one, in this case, y equals 1. The eccentricity is c over a. Yes, that's right. Sometimes I turn that backwards for some reason. Our a is 3. A squared is 9. A is always the bigger value. So we have 3 over square root of 5. Now, the more this ellipse becomes a circle, that means that upside down.
Square root of 5 over 3.
The more C becomes closer to the center, the more they work in, that means this ellipse is becoming a circle. It's becoming less eccentric. And if this was to hit 0, that would be an exact circle. So if you drew a very eccentric ellipse, these focal points would be way out here, very close to the edge. Like the path the Earth takes around the sun is not, it's very close to a circle actually. It's not eccentric at all. So the C for the Earth around the sun would be very close to 0. Any questions on that? How about x squared plus 2x plus something? Take a 25 out, y squared minus 4y plus something is equal to negative 76 plus something plus something. You got to add the same thing to both sides. It's illegal not to in Nebraska. 1. 1. 4 divided by 2 is 2. 2 squared is 4, but we really added 100 to the left side, so we have to add 100 to the right side. Now this factors into x plus 1 squared plus 25 times y minus 2 squared, and that's equal to 25. We want this equal to 1. When we do that, easy to tell all the information. All right, so we have x plus 1 squared over 25 plus y minus 2 squared. This is really over 1, even though we wouldn't really write that. Identify the center, negative 1, 2. It's not so important. With ellipses, we usually just write the x first and the y second because it doesn't really matter because it's plus. But with hyperbolas, make sure you keep x with x and y with y because we switch those. So x with x, y with y, make sure they're opposite. Let's start graphing, negative 1, 2. The vertices, well, let's graph it. Under the x is 25, so we'll go right 1, 2, 3, 4, 5, left 1, 2, 3, 4, 5, up and down 1. So this is a very eccentric, much more eccentric than what we had before, an eccentric ellipse. The vertices are always the farthest point away from the center. So that's going to be 1, 2, 3, 4, 2, 4, 2, and 1, 2, 3, 4, 5, 6. Looks like negative 6, 2. Focal points, we have a squared minus b squared equals c squared. It's always opposite of the sign in the equation, always opposite. 25 minus 1 is equal to c squared, so c is equal to plus or minus 2 square root of 6, in other words, square root of 24. But like I always say, just make sure you don't get a negative value, right? You can't take the square of a negative. Well, now that's not the focal point, that's the tool I'm going to use to find the focal point. All the focal points, let's see, square root of 24 is just under 5. 1, 2, 3, 4, well, it's right there. It's right up against the edge because this is a very eccentric ellipse. If it's very eccentric, those focal points are way out to the sides. We'll notice that all the y values are the same. They're all 2. And we have 1 plus or minus square root, well, no, 2 square root of 6. Square root of 24. The major axis is the longer axis, and it sits on the line y equals 2. The minor axis goes through the center. It connects the co-vertices, and that's sitting on the line x equals negative 1. And finally, the eccentricity is 2 square root of 6 over, I need the a. A is 5 over 5. Graph the following parabola. Yeah, complete the square on y. I'm glad some of you find that funny because my Algebra 2 kids, they don't. They're like, oh, that sounds right. Yeah. There's a pair of them. Plus something on both sides. 4 divided by 4 is 4 divided by 2 is 2. 2 squared is 4. So we have plus 4. Y plus 2 squared is equal to 8x plus 18. Well, in order to get what we want, we need that the coefficient of x to be 1. Let's factor out an 8, 9/4. So we get a fraction, but that's okay because we don't really have to do a whole lot with this fraction, quite frankly. Once we plot it, we're just going to move from that point. In other words, we're going to get negative 9/4 comma negative 2, which is negative 2 1/4. Negative 2 1/4, negative 2. And that's really about all you have to do with fractions, as far as plotting these parabolas. 4p is equal to 8, so p is equal to 2. That means the focus is 2 units from the vertex. And since y is being squared, when y is squared, this must open right or left. P is positive, so it must open to the right. And we're 2 units away, so there's your focus. And notice I really didn't have to work with fractions. I just go 2 nice steps to the right. That means the directrix is 2 units on the other side. So that should be a nice straight line on the other side. And then if an 8 is sitting here, we're going to split the difference over the focus. We'll go 4 up. We'll go 4 down. And that's a very quick and easy way to get 2 more points that are on the parabola. And since we know what a parabola looks like, we don't have to plot 100 points to get a pretty good idea of what it looks like. Now that might be a little bit off, but we're not going to get out the rulers and make sure it's exactly on the right spots. Any questions?